Hello, my professors. You are welcome to today's lesson. And in today's session, we are going to look at the solution to the class test, okay, on functions and simultaneous equations, just as you have on your screens. Okay, so I'm going to walk you through the solution, which happens to be the marking scheme as well. So it's supposed to help you, okay, mark yourselves if you want to, but you are supposed to anyway. So guide you to mark basically. And I've told you that as a student, if you know how to mark, it puts you, you have an edge over your other colleagues, okay, who don't know how to do that. So stick and stay with me whilst I walk you through the solution. I'm Mr. Hackman, your usual facilitator for mathematics. Okay, so now let's go and look at what the first question. Okay, so you can see that in fact the questions that you were given, you've seen almost all the questions, you've seen it before, either directly or for some of them, there was a little variation. Okay, I changed the question or the questions a little. Okay, but please take note, I've gone through your submissions, okay, and I'll factor all the concerns that came to bear from your various submissions. Okay, so now straight to the solution. Okay, so you can see the point is you've been told, okay, the advice, anytime I read questions, I have to make it a point to underline the salient parts in the quest to protect my marks, especially the low hanging marks. So in this case, okay, if you read this, find, so 1A, find what values of x is 1 over s plus 1 over s plus 2 undefined. So you underline this. So you're looking for the values of s for which your expression that you have there will be undefined. Okay, then, okay, B, we'll come to B. I'll read B when we get there. Okay, so let's see, so with this one, for which the function is 0, so you underline, okay, 0, for you to know that you are looking for what? The zeros. Okay, the values of s, that will make your function that you have there 0. Okay, so now straight away, let's go and look at the solution. I've told you, anytime you read question after underlining the salient part, the first thing that you write is solution. So those of you who did not write solution, please take notes. Okay, the total marks for question 1, you divide it by 2. That will be your penalty. So it means if you have 12, you are going to score 6, provided you scored everything that you have there. So it means if you add 5, okay, you are going to have 2.5. Any mark that you get, you divide it by 2. Okay, so now let's quickly go and look at this. So here, as usual, solution. After that, you normal your question. As for the question, failure to normal your question exactly, precisely, you are going to lose the entire marks here. So for you, you have M0, A0, so you are going to get 0. So you are done with marking this particular question, question 1. If you normal question 1, okay, wrongly, this particular question wrongly, you score 0. So you are done marking. So listen to us, basically. Please go strictly by the instruction for marking. Okay, all right. So now what do? Every question you extract what you are given. So here we are giving this expression. So you extract, with your ability to extract that one will give you B1. You can see the marks there. I won't talk much about the marks. Okay, so after that, remember, we said you have to come and write for undefined, and you always go for the word that is used in the question. Okay, so in this case, for undefined, if it was not defined, then you use not defined, though the two can be used interchangeably. But the advice is go for what is in the question. So for undefined command, I've told you that anytime you have fractions, okay, for your entire fraction there to be undefined, at least, okay, one of the denominators should be 0, or both should be 0. So meaning you set each of the denominators containing your variable, okay, to 0. So in this case, it means for this fraction alone to be undefined, x must be equal to 0. For this fraction also to be undefined, x plus 2 must be equal to 0. So you write x must be equal to 0 using this fraction, the denominator, or the denominator here should also be equal to 0. So here x is solved for, you come and solve for x here, and that will give you x to be equal to minus 2. You can see the marks there. Now you come and draw your conclusion. Therefore, s is equal to 0 or minus 2. If you don't draw your conclusion, you will lose the mark here. Please take note. So you will end the marks up to this point. You will lose this. Remember, it's always extract, conclude, or giving conclusion, giving therefore or hence. All right. So now what do we have? You go to B. We are done with the A. B, you extract this function and take note. Surprisingly, I don't know why. I've been telling you times without number. Some of you are still extracting the function in the arrow form. I've told you never in your solution should we see a function, okay, given in the arrow form. The arrow form, they are best seen in questions. So it means you extract this in its corresponding relation form. So that will be this. Those of you extract it in the arrow form, you won't get the B score here. Take notes. So you will get B0. Okay, fortunately for you, B is equal to 0. That doesn't mean everything will be 0. If it's M, then okay, everything, okay, whether you get it right after that will be 0. So take note. So at this point, we are looking for the 0. So you write for the zeros, and I told you that the zeros, there is no E. Some of you brought E, okay, and E. So please take note, be careful. This one is just English. So I'm not going to penalize you. So just be careful. So for the zeros, you know, for a fraction to be 0, unlike the undefined, where the denominator should be equal to 0, the zeros, if you are finding a fraction, for a fraction to be equal to 0, the numerator must be 0, because 0 over any number is what? 0. So you set the numerator this time around to 0. And you can see that you have a cubic expression, okay, here, and the equal to make it a cubic equation. I've told you here, you should be able to deal with it. How do? You have to factorize. So here, we can factor s squared out. So if you do so, this is what we are going to get. Then after that, we are going to, having factorized this side, and this side is equal to 0, we use a 0 product rule. So that means s squared is equal to 0, and the connector here is critical. Okay, if you don't bring the or, it will be M0, A0. This one too, if you don't bring the or, you have to be careful. Okay, you will lose the entire mark here as well. So take note of that. That was just by the way. So in this case, what do? We are supposed to come and take the square root of this side. So it will be square root of s squared is equal to plus or minus square root of 0. By 0, we don't have plus or minus, so it will be square root of 0. And here, this is a special situation. So you should know that you are going to get s equal to 0. So you can skip the point where you have to take the square root. Okay, this one is a special situation where you have this side to be equal to 1. You are taking the square root of the side to be 1. Then here, you come and solve for x here. So that will give you s equal to 1. You come and neatly draw your conclusion. Therefore, s is equal to 0 or what? Or 1. So that will be it for question 1. And the total mass for question 1 is what? Is 12. Now let's move on to question 2. Okay, question 2, let's see whether there is any salient part for us to underline. We are given two functions, J and H are defined by, so this is your function J given in the arrow form or the mapping form, and your function H also in the arrow or mapping form, where X is a real number. A, we are supposed to evaluate this. So, okay, this question, I think I gave it to you directly, okay, in one of the videos that I sent to you to help you prepare for, okay, the test. All right, then the B, this is what we have. So quickly, let's go and look at the solution. So as usual, you write the major question number, and that is 2. Where you have the question 2, is there any information that can be extracted? Yes, that is the two functions given. So you can see that I've extracted the function, the two functions here. Some of you wrote A here, but be careful. You can see that the information that you are extracting here, okay, the question number there is not A, it's not 2A, it is really 2. It's A that you have that information, but I'm going to pardon you. If you write A here, then it means this information that you have is only a general information for A. Meanwhile, it's for question A and question B. So as you extract it here, it means we can rely on it to do the A and the B. But if you brought the A here, ordinarily, when you are going to do the B, you have to extract the same thing again. Okay, so you know that I've told you this. Okay, but I'm going to be lenient. If you put the A here, that's okay, but be careful next time. This information is only, okay, the question number where you have this information is only 2. Okay, so take note. Then A, if you come to A, you can see that it is A rather that you have this information given. So you extract that. So we need to perform, okay, or simplify or evaluate the expression that we have here. Once we know the two functions, we are able to evaluate each of the functions at each of the values given there. So now we need to find J of minus half, multiply it by the dots here, you know, I told you it's multiplication. multiplied by h of 3 all over j of 4 minus h of 5. So once we know j and h functions, we are able to evaluate. At the normal circumstance, we should have written equal to, then we'll come and substitute and simplify inside. But remember, or together. I remember I told you the advice is, if possible, unless maybe your numerator is just a single fraction involved, a single function, I should say, and the denominator is also a single fraction. Otherwise, if you see more than a function in either the numerator, the denominator, or both, take out whatever that you are asked to evaluate. I'm talking about the functions in a separate form, individual form, compute, then you go and substitute. So that's what I did here. I came to find, so I wrote but j of minus half. So I came to find j of what, minus 5, minus half, then I did j of what, 4. So I did all the j functions that I'm supposed to evaluate, using certain values, feed it with certain input. So j of minus half will be equal to, wherever I see x in j of x, it is what, minus half. So this is your j of x. So I'll get to this x here, I put it in brackets minus half. It has squared, then what, minus 1. So you can see the marks there. Then I know before I cannot cancel this way, before I can cancel, the power here should be 1. So I have to deal with the exponent to the power first, before I think about any cancellation or any multiplication. So that will give me minus half squared will be minus half times minus half, and that will give you 1 over 4. So or minus 1 squared, which is 1, then 2 squared, which is what, 4. Then minus your 1 is still there. So here you can cancel because the power is now 1. So if you cancel, you are going to get 1 over 2 minus 1. And here you don't need a calculator. 1 over 2 minus 1 will give you minus half. So that will be the value of j of minus half. You come and do same for j of 4. So that explains what I have here. To this point. So that will give you 31. Then you come and do h of 3 and h of 5. So h of 3 means wherever I see x in h of x, it is what, 3. And remember, this is h of x. So this x here becomes what, 3. So it will be 3 into 3 plus 2. So that's what you have here. And as you move from this step to the next step, you move close to the margin or rise close to the margin. So it will be this time this 9 plus 2, which will give you you do same for the h of 5, and that will give you 17. So now at this point, once you know this, you know this, you know this, and that, we are able to find the whole of this. So I come and write, therefore, whatever that I'm giving here will be equal to, then I go and substitute their respective what values. So I had the j of minus half to give me minus half, then the h of 3 to give me 11 all over. Someone can use the times symbol, this symbol, or can use the dots. I decided to use the bracket to represent the multiplication. So now over your j of 4, which gave us 31, minus h of what, 5, which gave us what, 17. So after your substitution now, you just need to know how to simplify this. So don't use your calculator for the whole of this. Deal with your numerator separately and the denominator separately. So that's going to give me minus half times 11, and that will give me minus 11 over 2. The whole of that it will be over, but I know that this will give me just a value if I simplify. So I can change the over to the division symbol, the division bar to the division. So it will be divided by 31 minus 17 will give me 14. So now I will get this one, change this one to multiplication, then I will get 1 over 14. Someone can move from here to here straight away. So if you move from here to here straight away, then you add this 1 mark to this mark so that this will be M2. You won't lose any marks. So you can do that without. So that's the matured way. You can change the the division to multiplication and invert. So if you multiply this, we are going to get minus 11 on what? On 20. And remember, therefore, is already here. So I've drawn my conclusion. If I put implication here, then I'm going to write, therefore, whatever that I have here is also, I have to draw my conclusion. Or after doing it separately, some of you who did that, be careful. Once something has interfered, you cannot straight away come and write equal to, and come and write this without writing the side. So those of you who did that, you get, provided you did the writing up here, you get only the marks up here. From here going, it will be M0, so you lose all the 4 marks here. So my point is, at this point, where you have found your corresponding values of whatever function that you were asked to evaluate there, each of them, okay, in what you are asked to evaluate. And you come and write equal to, after doing all that, then come and write equal to half minus half, okay, maybe times 11 over 31, okay, minus 17. Please, what is equal to this? Because what you have above your equal to now, which will be this. So it means it is the 17 that you are saying is equal to this, which is wrong. Remember, I've told you, any expression that you write and something interferes, if you are going to use that expression again, work on that expression, you need to write that expression before you come and write equal to. So I guess my point is well made there. So now let's continue to the B. Okay, so the B, we are asked to find, okay, the values of x if this equation, okay, is satisfied, or the values of x that will satisfy this equation. Okay, so in this case, we are given, you extract as well, g of x minus 1 minus 7 is equal to 0. So now we need to find g of what? X minus 1. So this function is evaluated as an expression. And remember, when we did function, we did the evaluation of function at specific values and at expressions, at constant and at expression. So please take note. So in this case, it means wherever you see g of x, you put x. So wherever you see x in g of x, I should say, you put x minus 1 there. And remember, you have already extracted your g of x. Okay, so that was extracted here. So it means this x here, okay, must take what? X minus 1. So I'm going to here. So it means wherever I see x here, okay, it is what? X minus 1. Okay, it is x what? Minus 1. So I'm going to get 2 into x minus 1, but the x here is as a power. So it means your x minus 1 that is replacing the x will also have a power 2. Then you are not done. It will be minus 1. So that's it for the g. What's the first two terms that you have here is for g of x minus 1. Okay, then minus what? Your 7 that is here. So please take note. So if we're asked to find, okay, you are given this, let me write it here. Okay, so that those of you who couldn't at that point, I realize that some of you couldn't relate very well. So if you are finding g of what? X minus 1, it means wherever I see x here, it is x minus 1. So that will give me 2 into x minus 1 squared, then minus 1. So what you have here, the whole of this, is what we replace the g of x minus 1. So the whole of this will replace the g of x minus 1. But that is not all, then it's minus 7. So that's why you have the minus 7 here. Okay, so I guess my point is well made, then it's equal to 0. So at this point, again, you cannot multiply until you deal with the power. So you are now expanding a binomial square. So we know how to expand binomial square. So this will give us the first quantity squared minus twice the product of this and this, which will give us the 10 plus 1. That's the 1 squared, which will give us this. Remember, as you are dealing with the power, the 2 is there, so your bracket will still be there. Okay, so failure to put the 3 times here in bracket will be costly. If you can't use the identity, which is what? Your a minus b squared is equal to a squared minus 2ab plus b squared. If you can't use that identity, just take what? X minus 1, okay, squared. You know this is the same as x minus 1, expand and combine like terms. You end up getting this, what you have here, then you come and put it in bracket. Okay, but do that as your rough work. Okay, other than that, if you do it here, you write a lot. Because as you are expanding this, you'll be writing the other terms that you have here as well. You need to write them. Well, but I think I've made my point. So at this point, push in the 2. So multiply each of the terms here by 2. So that will give us what we have here. Okay, then remember this is not being multiplied by 2, the minus 8. All the 3 terms here that you multiply by the 2. So at this point, okay, move the bracket and simplify, you end up getting this. Okay, some of you started solving your equation at this point, but please take note. I've told you before you solve your equation, check whether you can clear the fraction. Okay, check whether you have removed all the brackets, and check whether, again, you can reduce your equation. So obviously, you can see that we can reduce this equation by dividing through by 2. Okay, so now what do? I divided through by 2, but my this side contains more than a term, so I did the division by 2 mentally. So you can equally do that instead of writing this 1 over 2, this 1 over 2. Okay, so in that case, this over 2 give me mentally s squared, this over 2 give me 2s, this over 2 give me minus 3, so it's equal to 0. And again, thankfully, our leading coefficient is 1, so it means we can factorize, okay, without going through the factorization by grouping. So once you have that, it's a quadratic in x. So if I'm factorizing, I will get 2 factors. Okay, it's an x, so I'll get x, that's what you write first. Then you use the factor pair. So I'm looking for factor pair of what? Minus 3, which when I multiply, I'll get minus 3. I add, I will get what? Positive 2, and that will be minus 3 and positive 1. So someone could have done, okay, minus 3 plus 1. I decided to write the positive first, so plus 1 minus 3. So that will be the factorization of this side, and it's equal to 0. So you set each of the factors here to 0. And remember, when you set it to 0, the connector is all. Any other connector, it will be M0, A0, or if you ignore the all together, you get A0, M0, A0. So and now you come and solve for your x here, x will be equal to minus 1. Solve for x here, x will be equal to 3. So you come and draw your conclusion. So these will be the s values that will give. So you write therefore x equal to minus 1 or 3. Okay, so that will be it. So those of you concluded by writing therefore the value of x, no. Remember, I've told you, when you are asked to find the value of something, okay, just write that something is equal to the values or value that you have there. Please take note. So that will be it for question 2, and that will attract a total of the A and B 31 marks. So now let's move on to question 3. Okay, so question 3, what do we have? Okay, so question 3a. All right, function h is defined by h of x. Okay, so what have you? And let me quickly add, let me go back, okay, to this. I think I said this. Those of you who extracted your functions in the mapping or the arrow form, you won't get this mark. Okay, so as for that one, you should know. So that will be B0. So now let's go back to, okay, our question 3. So question 3, this is the question we've been given. H is defined by, okay, this where a and b are constant if the image of 1 is minus 6 and that of 3 is minus 12. Find the values of a and b. So you have, okay, an equation here with 2 unknowns, okay, or a function here with 2 unknowns. If I can find these 2 unknowns, then I need to generate 2 equations at least for these 2 unknowns. So I have to fish out for or look for information in the question that will help me set, okay, these 2 equations. That will help me find the 2 unknowns. Okay, so now there is nothing salient to underline, and maybe unless you want to underline this, but it will be extracted mathematically anyway. So in this case, you write, okay, question 3a. This is the information that I'm giving. My function, it came in the arrow form by extracting the relation form. Those of you extracted in the arrow form, that will be B0. Then now we come to, you are told the image of 1, okay, is minus 6, means h of 1 is minus 6, you know. Okay, so, but h of 1 is equal to minus 6. So I've extracted this information. So that is B1, and this one is a fact you need to know. If you're able to write this B1, okay, then what do I do? Now I use this one to form my first equation. So this implies that, so h of 1 is wherever I see x in what? In h of s, I put 1 there. So that will give me a into 1 squared plus b into 1 minus 2. I'm told this should be equal to minus 6. So I come and remove the brackets, and that will give me this. And here, because what you have in bracket is 1, okay, you can straight away multiply, because 1 to any power is 1, so I can multiply without dealing with the power. That's a special situation. Okay, that is 0 and 1, special situation. Okay, so that will give me this. You know, every equation, usually you want to maintain the lettered terms on one side and the constants on the other side. So I'll move this one here, and that gave me this before I labeled my equation. Then again, I'm told that, okay, the image of 3 is minus 12. So the meaning of this statement is that h of 3 is equal to minus 12, and h of 3 is equal to minus 12. So you go by the same. So you use this relation here, equation here, to generate what? Your second equation. So in this case, what do I have? A. So this means wherever I see x this time around, it will be 3 in h of x. So that will give me a into my new x is 3, okay, square plus b into x. My x now is 3 minus 2 is equal to minus 12. So with this one, you cannot multiply. Okay, you have to deal with the power first, because the number in bracket that you are raising to the power is not positive 1 or 0. So at this point, deal with the power. That will give us 3 squared, which is 9 times a. Then b, you multiply this one, you can remove. You don't have, the power is 1, so you can multiply straight away just as we did there. So now what do we have? This will give you 9a if you remove the bracket. And okay, this side will give you this. So the next step, you know, maintain your letter terms on one side and move this one to the side. That will give us minus 12 plus 2, so it will give us minus 10. This cannot be reduced, so you label this as your equation 2. So at this point, you've generated your two equations. Like I always tell you, or I told you when you were dealing with a simultaneous equation, listen to the equations they talk. They will tell you as to the best method to use, be it the elimination method or the substitution method. So if I look at this, okay, two equations, equations one and equation two. Okay, equations one and two, I should say, or equation one and equation two. If I look at it critically, okay, if I want to use elimination, okay, if I want to eliminate, I have to make, okay, the coefficient of, what do you call it? If I want to eliminate B, I have to make sure that the coefficient of B, okay, in the two equations will be the same. If I want to eliminate A, the coefficient of A in the two equations will be, okay, the same. So here, my intention is to eliminate what? A. Some of you use the substitution method, and it's very fine here because you can make A the subject without involving a fraction, B the subject without involving a fraction. Okay, so that ordinarily would have been ideal. But remember, I told you I usually want to use what? The elimination method. Okay, so if you use that method, then it means look at the marks that we have here, okay, up to where you get the values of the A and B. Okay, then give yourself that mark, meaning your steps will not be the same as what I have here. So indirectly, I have directed you as to how to allocate your marks in that situation. So in this case, I want to eliminate what? A. So in that case, if that's the case, okay, so sorry, I want to eliminate B. So if I want to eliminate B, then I have to multiply equation. I have to make sure that the coefficients are the same. So I multiply equation 1 by 3. So you can see that equation 1 times 3. And some of you are still writing, labeling your equation this way. Remember, I've advised you to avoid using that. Don't write equation this way, equation 1. Okay, don't, this is not necessary. Don't do, just do this, the right ones in a circle or in brackets, sort of. Okay, don't write that. So, and this one, to some of you write multiplying equation. No, just write the one, the name of the equation times 3. Mathematically, this means equation 1 times 3. And this will always be too short to take a line. So, comma, some of you came down, but please take note because of constraint paper. So, too short to take a line, either comma, semicolon, or colon. But I said I usually want to use comma. Then you have what? So that means this equation 1 times 3 will give me 3a plus 3b, okay, then minus, or 3 times 4, which will give us minus 12. So that's what you have here. So that I will call it 1a because I worked on equation 1. So I will now come in, okay, my intention was to remove, okay, or eliminate the b. So by the b, okay, so now I have two equations with the coefficient of the b being the same, this and that. Okay, so but they have the same sign. So if I want to eliminate, I have to subtract. So I did equation 2 minus equation 1a. Someone can do equation 1a minus equation what? Equation 2. Okay, I usually want to use what? The letter that I am looking for. Okay, so the equation with that bigger value containing that letter, the bigger coefficient, will tell me that I need to subtract the other one from the equation with the bigger. So that's the more reason why I did. If you look at this, 9a, this is 3a. 9a is bigger than 3a. I want to subtract so that I will avoid negative, okay, result for what's the quantity that I'm looking for, negative coefficient. So that informed my decision to go for equation 2 minus equation 1a. So you just write it this way, comma, and again, it will be too short to take a line. So you did 9a minus 3a, that will give you 6a. 3b minus 3b, that will go 0. You don't write it. That was your intention. So b has been eliminated. Minus 10, okay, minus 12. So it will be minus 10 plus 12, and that will give us 2. So at this point, you know you are looking for A. You write it again before, okay, you divide anyway. Okay, so that is it. I think, okay, this should have gone. So let me have repeated this statement. So let me quickly do the needful. Okay, then it means I have to alter the marks again. Okay, so please let me do the needful. I think I repeated that, which you shouldn't be. You know, I've told you to always avoid. All right, so I have effected the change. Okay, so I remove that step. Okay, and giving the marks somewhere. So the total marks will be intact anyway. Okay, so I didn't give it to the previous one. So the next one will be there. Okay, that was just by the. So now you write it again before you divide. And when you divide and you reduce, we are going to get this. So you will need A. You get A to be equal to 1 over 3. You will need A to find the B. So you label this as equation 3. Then you go and substitute equation 3 into what? Any of the two equations, but preferably the equation involving, I mean, simple equation, the pretty equation, as I usually say. So between equations 1 and 2, you can see that equation 1 is okay, is simple. So I went for equation 1. That doesn't mean you cannot go for equation 2. So it will be equation 3 into equation 1. And don't write substitute, put. I've told you, those of you who wrote put, who wrote substitute, at this point it will be minus 2. If you want to write, I told you, write substituting, putting. But again, I told you that you can avoid that. Just write this. This means you are putting equation 3 into equation 1. So if you wrote put, putting, or sorry, put or substitute, that one will give you, what do you call it, minus 2. That will be the penalty. It means you are not listening, you are not doing the right thing. Okay, so it's you shouldn't get the same marks as the person who is doing the right thing. Okay, so that will give you, and those of you who wrote substitute, sorry, substituting, putting, okay, that one too, I discourage you from doing that. So for you, it will be minus 1. Those who wrote put, okay, substitute, minus 2. If you wrote putting, substituting, again, it will be minus 1. Take note. All right, so now I go, so it will be too short to take a line, comma. Then what do I do? Wherever I see A in equation 1, it is 1 over 3. So 1 over 3 plus B, okay, which is what is equal to minus 4. Then now what do? I clear the fraction. Someone can move this one to this side. Okay, but I clear the fraction, multiply through by the LCM, which will be 3. So this time 3 will give me 1. This time 3 will give me, what do you call 3B? This time 3 will give me minus 12. So I come and solve for B. I move this one to the side, minus 13. Write it again before I divide. So I had B to be equal to minus 13 on 3. So I come and draw my conclusion. Therefore, A is equal to 1 over 3 and B is equal to minus 4 whole number 1 on 3. Remember, you don't conclude with an improper fraction unless otherwise stated. As for decimal, no. Okay, you avoid decimal totally. So those of you who concluded with the improper fraction form of the B, you will get only A1, so it will be minus 1. Okay, if you had your conclusion drawn with any of the two values wrong, okay, any error, okay, will be minus 1 in your conclusion. So take note. If you concluded with minus 13 on 3, for the B, it will be A1, not A2. Take note. Because I've told you on countless occasions that you avoid concluding with an improper fraction unless otherwise stated. Avoid concluding with decimals unless otherwise stated. Okay, so if you concluded with decimal for the 2, it will be A0. Take note. All right. Okay, so now let's go. Okay, for the last, no, I think we haven't done the B. So we are going to look at the B, also one of the easiest, okay, questions. So question 3B, okay, what are we giving? We are giving this and we need to find the value of K. Okay, so first of all, we are giving our function, it came in the relation form, we thank God. So we are extracting the relation form and f of 5 is equal to what? 8. So in any case, you can see that in this function, the relation that we have there, it contains only K that we are supposed to find. The X we will know, okay, by feeding it with 5. So after feeding, we will get only the K. So it means I need one equation to solve for the K. So this information will help me do justice to, okay, that. So wherever I see, so this implies that if f of 5 is equal to 8, then this implies that K over, so f of 5 means wherever I see x in f of wherever I see x in f of x, I replace or I put 5 there. So it will be K over this x will be 5 plus 1. That's what I have here. Then 6 over this x will be 5, then plus 2. And that we are told should be equal to 8. So now the denominators I can simplify or combine. So that will give me K over 6. This will give me 6 over 7 is equal to, and again, you clear the fraction. Someone can choose to write this as a single fraction, then cross multiply is also allowed. So if you did that, okay, then from here going, the mass that we have there in between here, okay, you give your marks there, the total, so sum, then put the total mass. Then by your conclusion mark, we should all conclude this way. So it should be the same. The variation will be from here up to this value where you had it. So in this case, you know, the LCM will be 42. So you multiply each of the tens by 42. Someone can choose not to show the multiplication by 42, okay, because the side contains more than a 10. Okay, so it means someone can move from here, okay, to here straight away. If you did that, then you are going to give yourself, okay, M3 here. Take note. You will lose marks. Remember, if one side contains more than a 10, you can multiply, you can, okay, divide without showing. Okay, so at this point, I am solving for my case. So I've generated one equation in K, and a simple equation for that matter, linear. So I move this one to the side, which will give me, okay, 7K is equal to 300 because I'll get 336 minus 36. Okay, so 336 minus 36. Okay, so that will give me 300. I write it again before I divide it. I end up getting this. So those of you concluded with an improper fraction again, you will lose the marks for your conclusion because you avoid concluding with an improper fraction. You've been told several occasions. So if you change this one to its corresponding base numbers, which your calculator can do that, if you don't want to use your head, okay, then you conclude that, and that will give you your A2. So now to the last question, question 4. Okay, so let's look at question 4 quickly. Okay, so question 4, what do we have? Okay, A, we need to find the value of y. In fact, the team assignment, these two questions were questions that came in the team assignment. Okay, the team assignment is exactly this, only that you were asked to find the value of x. Okay, and this one too, the B, I think I use U and V. So I just change the letters in the equation, okay, from U and V toward P and Q. As simple as that, but it's the same question. So if you took part in the team assignment and contributed, you would have to find this question, okay, or you have this question very easy. So as usual, question 4A, you extract your first equation. And remember I said any equation, if you can clear the fraction before labeling, you do so. But you know, every rule there's an exception. I told you that if your variable, okay, I mean your denominator are variable denominators, don't clear the fraction. Okay, you clear the fraction when the denominators are, okay, normal or constant, okay, what do you call it, than variable denominators. So here, I didn't clear before labeling. The second one too, I didn't clear before labeling. So B1 for this, B1 for this, which will give us B2 if you extract correctly. Then now, okay, I want to, which of the letters am I supposed to find its value? That is why. So I will need to, if I want to use the elimination method, I have to eliminate x. If I will use the substitution method, then I have to make what x the subject. So I decided to use what the elimination method. Remember, I've told you that's my comfort zone. Okay, and usually the elimination method, okay, saves time. Okay, now what do I do? If I want to eliminate x, okay, then my numerators must be the same so that when I subtract, I can what? Eliminate the x. So how do I make my numerator here 2? Because here is 2, the here must also be 2. Okay, if I were supposed to, as I explained in the video for the team assignment, if you are that one where you were asked to find the x, in that case, you eliminate the y. If you want to eliminate the y, then you have to make sure that the exponent here, let's say the power, the numerator here should be 5. So you multiply equation 2 by 5. Here, I want to solve for y. So, and I want to eliminate what? Y, x. So I multiply equation 1 by 2. So equation 1 times 2, comma. So it will be 2 times 1 over x, and that will give me 2 over x, minus 2 times 5 over y, and that will give me, I'm doing that mentally because this side contains, okay, more than a term. So that will give me 10y. Okay, so minus 10y, then is equal to 2 times 7, that will give me 14. So I label this as equation 1a because I worked on only one equation, equation 1. Then what do I do? If I compare equation 1a and equation 2, obviously I can see that these two terms are the same. Okay, but they have the same sign. So if I want to eliminate, I will eliminate by subtracting. So I subtracted, okay, equation 1a from equation 2. So I wrote equation 2 minus equation 1a, comma. So that will give me 2 over x minus 2 over x. So that will go the same quantity. So my x has been eliminated. So I will get, okay, now at that point, I'm going to get, okay, 1 over y minus 1, 10 over, okay, what do you call it, y. So it's like this, what you have. 1 over y minus, so it will be plus what? 10 over y. So if you write this,
as a single fraction, your denominator will be y. Once they have the same denominators, just add their numerators. So that will give you 11 over y. Okay, so in that case, I know, okay, my y term will be 11 over y. And it's equal to, you get, we said, okay, equation 2 minus equation 1. So it will be 3 minus what? 14. So that will give us minus 11. So now you cross multiply, then what? What do? You solve for what? Your y. So y you divide by negative 11 and what have you. Okay, so in this case, we are going to get y to be equal to minus 1. So you draw your conclusion for y. And remember the other approach where I said make a substitution. That one will be a long approach. Okay, so, and I advise you to go for this approach whenever you encounter this. So I equally, okay, adhere to that instruction. So now to our last question, that's the question 4b. Okay, also a simultaneous equation question. So with this one, okay, again, you extract. That will be B1. The normal circumstance I'm supposed to label, but remember, my equation here contains a fraction. In that fraction, the denominator is not a variable this time around, but it's a constant. So I have to clear the advice. So I multiply through by the LCM, which is 2, and that gave me P minus 2Q is equal to what's 2. If you multiply each of them by 2. So now I've cleared my fraction, and also I have my letter terms on one side and the constants on the other side. So I'll label this as equation 1. Equation 1. Then, and my second equation that I'm giving, okay, it's extracted here, that will be P1. So this one is direct extraction, P1. Then again, they contain a fraction. The fraction, the denominator is not a variable, a constant, so I will clear before labeling. So if I multiply through by the LCM, that is 3, I will end up getting this. Okay, but you know, okay, someone could have labeled this as what? Equation 2. Then it means the person has the intention of using the substitution method. Okay, so go and substitute the 2 into 1. Okay, maybe if this happen to be your 1, then you will solve for what? Your Q. Sorry, your P, to be in terms of P. Okay, but I don't want to use elimination at this point. So I will clear going by my usual. So let me clear, make sure everything is on one side. Okay, then I mean the letter terms are on one side, the constant. So I move this one here, move this one. That gave me this result. Then I came to, so I'm now studying these two equations. Okay, which method would be ideal for me to use here? I mean, these two equations, this and this. Okay, elimination, if I want to eliminate, I have to multiply this one by 2. Okay, so I can do that, but I just decided to use the substitution method so that some of you will know how to do your presentation with the substitution method. Ideally, I would have gone for the elimination method. Okay, once I need to multiply only one equation before I can, by a constant before I can eliminate, I would have gone for that. So here I decided to go for the substitution. So the substitution, let me see. Okay, these two equations, if I want to use substitution, then I have to go for the equation, a letter that I can make the subject without involving, okay, a fraction. Okay, so it's only this equation 1 that I have the coefficient here to be 1. Okay, as I've told you, if it will not involve a fraction, in that equation, the letter should have a coefficient of either +1 or -1. So it is only in this equation that you had that, okay, satisfied. So I will move this one to the side. So I wrote from equation 1, comma, P will be equal to, and obviously you know it to be 2 plus 2Q or 2Q plus 2 is the same thing. I labeled this as equation 1A. And I went to substitute equation 1A into equation 2, comma. So that gave me this, whereby I see, okay, P in equation 2. I substitute what? The 2 plus 2Q. Remove the brackets, combine 9 times and simplify, and that will give us, okay, Q to be equal to 3. Okay, now, okay, you know the value of Q. So you need this value to find your P. So you label this as equation 3 and go and write equation 3 into, this time round, put it into the equation that you made P the subject. The substitution method is always like that. After finding one value, you put it in the other equation that you did the change of subject. So equation 3 into equation 1A. Okay, that will give us P to be equal to, if you substitute, you know this is now what's 2. And combine this, so you get P to be equal to this plus, okay, this will give you 4. And so at this point, remember, okay, we should have underlined this in the question when we read it. Okay, so true set to protect our marks. Okay, so at this point, okay, I know that I have to conclude in the true set form. So therefore, okay, P comma Q is such that P is equal to 6 and Q is equal to 2 in the true set form. Okay, those of you who didn't conclude in the true set form, you will lose the entire mark. You won't get anything, so it will be A0. Take note. Remember, I have given you all the tools to help you protect your marks. So if you decided to be recalcitrant, not to do the right thing, okay, then it means you are ready to lose those marks. Unfortunate though. All right, so you know the rule. Okay, here now I think that will be it for okay what we have there. But that is it for the first part of the question. We are not done. The second part of the question we are asked to evaluate this. So now let's move on to, and you can see I told you that again when you read question and you see hence, you have to underline hence. So it means here would have underlined these two. Okay, hence and what? And the true set. So hence means the second part of the question. Hence basically means make use of the previous result. So again, when you are presenting your solution, you write hence. Okay, whatever that I'm giving here is equal to, once I know the values of P and Q, I substitute. If I substitute, I know. Okay, before I multiply, let me check if I can reduce. So 3 will go here too, so I will get 5 times 2, which is 10. Here I cannot reduce, I have to multiply, so I'll get 6 over 5. And I know, okay, if you use your calculator, you are going to get 11 whole number 116. Okay, if you use your calculator, maybe calculator will give you an improper version of what you have there. Please take note, an improper version, fraction version of what you have there. But you cannot conclude with that. You change it to what? Mixed number version. Okay. However, I did this mentally. Okay, so I know that 5 over 6 will give me one whole number, 1 over 6. So if I come and add the whole numbers, I'll get 10, then plus the one whole number, that will give me 11, then my fraction will come, 1 over 5 will come. So I did that mentally. So you can equally do that, okay, or you resort to the use of your calculator. On this note, I would want to say, okay, so the total mass I should say before. Okay, so with this one, the total is 25 for question 4. So in all, we are going to get a grand total of 100 marks. So you know the rule. Indicate your score over the total score. So if you had 100, it will be 100 over 100. If you had 90, you have to indicate 90 over 100. Let us always see the denominator. It should be clearly written on top of your first page or the last page below your last page. And it should be clearly written. When you are capturing your mark version, to capture it in such a way that that score over the total score will be okay visibly seen. Please take note. So on this note, I would want to say thank you very much for your attention. God continue to bless us.